In this lesson, we'll take a look at 3 examples of functions and determine if the functions are only injective, only surjective, bijective, or neither injective nor surjective. For a quick review, a function is injective provided every element of the codomain is the image of at most one element from the domain. And a function is surjective provided every element of the codomain is the image of at least one element from the domain. Notice both properties are determined by what happens to the elements of the codomain. They could be repeated as images or they could be missed. Injective functions do not have repeats in the codomain, but might or might not miss elements in the codomain. And surjective functions do not miss elements from the codomain, but might or might not have repeats. And bijective functions are those that do not have repeats and do not miss elements from the codomain. Bijective functions are functions that are injective and surjective. On the right, we have several mappings showing an injective function, a function that is not injective, a function that is surjective, and a function that is not surjective. So if these definitions are new to you, you may want to pause the video and make sure these all make sense. Looking at our first example, the domain is a set containing the elements of 1, 2, 3, 4, and 5, and the codomain is a set containing the elements 1, 2, and 3. So analyzing the function in two-line notation, notice all the elements in the codomain do appear in the second row, which is the range, and therefore we know the function is surjective because every element of the codomain is an image of at least one element from the domain. However, the function is not injective because the elements of 1 and 2 from the codomain are images of 2 elements from the domain, and a function is only injective when every element of the codomain is the image of at most one element from the domain. So because of the elements of 1 and 2 in the codomain, the given function is not injective, the function is only surjective. Let's look at our second example. Here the domain is a set with elements 1, 2, 3, and 4, and the codomain is a set with elements 1, 2, 3, 4, and 5. Looking at the given function in two-line notation, notice the element of 3 from the codomain is not in the range, and therefore the given function cannot be surjective because every element in the codomain is not an image of at least one element from the domain. But the given function is injective because every element of the codomain is an image of at most one element from the domain. The elements of 1, 2, 4, and 5 from the codomain are all images of one element from the domain, and the element of 3 from the codomain is an image of 0 elements from the domain, or is not an image at all, and therefore it does satisfy the definition for an injective function. This function is only injective. And now let's look at the third example. The domain is a set containing the elements of 1, 2, 3, and 4, and the codomain is a set with elements 1, 2, 3, 4, and 5. Well, because we have 5 elements in the codomain and only 4 elements in the domain, there's no way the function can be surjective because there's no way every element of the codomain is an image of at least one element from the domain. And the function is also not injective because the element of 2 from the codomain is an image of 2 elements from the domain, and therefore every element of the codomain is not an image of at most one element from the domain. And therefore this function is neither injective nor surjective. I hope you found this helpful.